Technology is advancing so fast nowadays that it's important to look back and remember how far we've come. From your smartphone to the TV in your living room, let's take a look at some past and present technology then and now. Data storage. We couldn't always rely on the digital realm to store everything from photos to messages. Data storage originated in the textile industry during the 18th century, when punch cards were used to record series of instructions from mechanical equipment like jacquard looms. These paper cards were later used to input data by hand punching holes and feeding them into a card reader, which converted specific sequences into digital information. Holes punched on each column would represent number of characters in a standard binary code, and entire programs could be represented as long as the stack of punch cards remained in order. By the 1960s, punch card methods were far less common, and in 1956, IBM also debuted the world's first hard disk drive. The IBM Model 350, which weighed over a ton, contained 50 24-inch storage disks worth a grand total of 3.75 megabytes and was leased to companies from $3,200 per month or $30,260 post-inflation. A decade later, this hulking machine was superseded by a new age of data storage, the floppy disk. These thin, flexible disks arrived in 1971 in 8-inch form, and later in 5 1/4 inches and 3.5 inches, and were written and read using a floppy disk drive. The original 8-inch floppy disk had a storage capacity of about 80 kilobytes, meaning you'd now need about 50 disks to store one 4-minute song worth an average of 4 megabytes. But by 1986, IBM introduced the 3.5-inch version capable of 1.44 megabytes. 1999 saw the arrival of the impressive and super compact SD memory card from SanDisk, Matsushita, and Toshiba. And in 2000, people were first introduced to the familiar USB thumb drive, initially capable of 8 megabytes of storage. Nowadays, USBs can support hundreds of gigabytes of data, and there's even a micro USB smaller than your finger and the thickness of a needle that can hold a whole terabyte. For comparison, you need 266,666 IBM 350s to hold that. Most people now rely on the digital capacities of the cloud, first introduced in 2007, which currently holds an estimated 1 exabyte of data, the equivalent of over 1 billion gigabytes. As Moore's law states that digital storage capabilities and speed doubles exponentially every 2 years, who knows what's to come? Mobile phones. In the modern world, smartphones are treated as a necessity, but the history of the mobile phone is a surprisingly short one. In April 1973, Motorola researcher Martin Cooper made the first cellular telephone call to announce that Motorola had won the mobile technology race. His device had a single-line text-only display, weighed 2.5 pounds, was 23 centimeters long, and only had a talk time of 30 minutes while taking some 10 hours to recharge. On September 21, 1983, the first commercial mobile, the Motorola Dynatac 8000X, became available, but still was a long way off reaching the masses. The device cost an eye-watering $4,000, over $10,300 post-inflation, and had a measly 20-minute call time, despite the battery weighing 4 to 5 times more than the phone itself. By 1992, the mobile phone was no longer reserved for business use or as a major status symbol, and the first to take advantage of the transition to digital consumer handsets was the Nokia 1011, which hit stores in 1992. This world-first mass-produced mobile phone could hold 99 phone numbers and was the forefather of the iconic Nokia 3310 model, which had SMS capabilities and helped the company dominate the market after its debut in 2000. It wasn't until 2007 that Steve Jobs and his collaborators transformed the industry again with the first-generation iPhone, which boasted a 3.5-inch screen, 8-hour talk time, and swanky new application features. Nowadays, there are over 150 mobile phone manufacturers in the world, but Apple is still considered a key innovator, with the recent iPhone 11 boasting a 6.1-inch liquid retina display and a whopping 256 gigabyte storage capacity. Reading. Reading is a historically valued practice. It can improve our worldview, mental processing, and education. But much has changed over the short of modern digitization. A few decades ago, picking up a book and reading it front to back was the primary way to consume narratives. But as technology has invaded modern households, reading has been transformed by laptops, smartphones, tablets, and especially e-readers. In 1997, leading innovator E-Ink developed a revolutionary electronic paper display technology which allowed a digital display screen to reflect light like ordinary paper without a backlight. This wasn't widely adopted until Amazon founder and CEO Jeff Bezos commissioned the world's best e-reader in 2004, and the race to revolutionize reading was on. As it turns out, Sony was the first to use e-ink technology in their library and Sony Reader e-readers in 2004 and 2006, but the concept didn't fully take off until Amazon announced the first generation Kindle in 2007. This compact reading device incorporated e-ink into its 6-inch display, featured 250 megabytes of internal storage, the equivalent of some 200 titles, and sold out within 5.5 hours. By 2015, eMarketer estimated that there were around 83.4 million e-reader users in the US, and in 2018, ebooks were expected to make over 50% of consumer publishing revenues in the US and UK. Amazon's newest water-resistant Kindle Paperwhite model now has a minimum 8GB storage, meaning it can store up to 2,000 titles. Considering some 1,400 books weighing about 1 pound each would be the same weight as half an average car, that's a whopping amount of literary potential to have at your fingertips. Computers. Without basic computing, modern tech like smartphones wouldn't even exist. But it's been a long road to reach this point. In 1880, punch card-based machines were relied upon for computing the US Census results after population growth meant it previously took several years by hand. But the true ancestor of modern computing was Charles Babbage's analytical engine prototype. Although never fully operational, this steam-driven engine marked a transition from mechanical calculation to general computing. And over a century later in 1941, the first general-purpose Z3 computer was developed by German scientist Konrad Zuse. Intended to calculate aerodynamics and aircraft design, this machine weighed a ton, still relied on punch tape for data storage, and was only capable of basic mathematical functions, with a top processing speed of just 5 to 10 Hz. The first mass-market desktop computer, the Programma 101, wasn't unveiled to the public until 1964. Priced at $3,200 or $26,550.50 inflation adjusted, this popular 65-pound device made computing compact and accessible, but could only support basic mathematical functions with a minuscule 240-byte memory. That means it could only store about 0.006% of an iPhone photo. Apple's landmark Apple I computer, which resembled a circuit board and required buyers to purchase parts like a keyboard and monitor, arrived in 1976 for $666.66, or $3,013.54 post-inflation. The system supported 4 kilobytes of storage and a 1 MHz 6502 central processing unit, which is 4,400 times less processing power than the most recent Apple Mac Pro, with 4.4 GHz. This desktop also boasts a whopping 1.5 terabyte storage. You'd need 18,750,000 8-inch floppy disks to hold all that. The Mac Pro is far from the most impressive modern computer on Earth though. IBM's Summit OLC-F is currently the most powerful supercomputer in the world. It has a whopping storage of 250 petabytes. That's 250,000 terabytes, or 250 million gigabytes, and is so fast that it's measured in floating point operations per second, or flops. The Summit is capable of a peak 200 petaflops. To give you an idea of how much processing power that is, it recently became the first supercomputer to reach exaope during genomic analysis, meaning it processed a quintillion operations per second. Laptops. As desktop computers made their way into offices, industry pioneers focused on compacting computing capabilities into something more convenient. The first truly portable computer, the Osborne 1, was created by designer Adam Osborne in 1981 and was about the size of a portable sewing machine, weighing some 24 pounds. The revolutionary luggable device had a 5-inch screen, 2 5 1/4 inch floppy drives, a modest 4 MHz CPU, and was priced at $1,795, about $5,080 inflation adjusted. In 1986, IBM then announced the first real laptop computer, the $2,000 or $4,700 post-inflation PC convertible, which had 256 kilobyte storage and a slightly more improved 4.77 MHz CPU, but which could also crucially run on battery power. Apple then entered the laptop market with the first Macintosh Portable in 1989, which had a 40 megabyte hard drive and 16 MHz CPU, but it was considered one of their worst products to date. Not only did it weigh 16 pounds, 3 pounds heavier than the outdated 13 pounds IBM PC convertible, and the same as about 5 modern MacBook Airs, it came with a hefty price tag of $7,300, nearly $13,500 post-inflation, and could barely store a few standard photos at an average of 6 megabytes each. Thankfully, the revised Macintosh PowerBook 100 model of 1991 fared much better with its 16 MHz CPU, expandable 40 megabyte hard drive, and more lightweight 5.1 pound frame, but it still pales in comparison with modern tech. The 2019 16-inch MacBook Pro, priced at $2,399 for example, has up to 8 terabytes of storage capacity, 100,000 times more than Apple's first laptop, and runs using a special 8-core 2.4 GHz processor, meaning it's some 240 times more powerful than the original Macintosh PowerBook 100. Calculators. If you need to solve something today, you probably wouldn't think twice about taking out your smartphone. But once upon a time, it took great amounts of machine processing to perform the most basic calculations. Back in 1820, a mechanical machine now hailed as the first incarnation of the modern calculator, the arithmometer, was patented by Thomas de Colmar and later manufactured between 1851 to 1915. To use this desktop-sized device, you'd simply select the desired mathematical function on the reversing lever, set your numbers using cursors with scales 0 to 9, and then use the crank, which would display the results in the totalizer windows at the top. During World War II, more complex calculating power was required for military precision, so a bigger, better machine was built to take on the job. The Electronic Numerical Integrator and Computer, or ENIAC, was the world's first general calculating computer, which was built in 1946 at a cost of $487,000, over $6 million post-inflation, by Pennsylvania University students. This machine could solve a larger class of numerical problems and was about 1,000 times faster than the electromechanical computers, but there were a few drawbacks. ENIAC required over 17,000 vacuum tubes, 70,000 resistors, and 10,000 capacitors, and weighed about 30 tons, filling an entire 30 by 50 foot room and consuming an insane 150 to 200 kilowatts of energy. It wasn't until 1967 that the first portable calculator, known as the Caltech, was produced by Texas Instruments, which printed results and was capable of basic arithmetic using 4 compact integrated circuits. By 1980, pocket calculators had reached the forms we still recognize today, with battery power and using single chips and LCD displays. Nowadays, even the most scientific calculators can be replicated using software, and smartphones come with built-in calculating capabilities. TVs. Television as a concept had been discussed as early as 1900, but it wasn't until 1924 that the first real steps were made. Scottish engineer John Logie Baird developed a way of passing a beam of light through a rapidly spinning disc punched with holes, so that a simple image could be scanned, transmitted, and reconverted. The first mechanical TV sets of the 1920s, such as the Baird models B and C, initially resembled large cabinets with a tiny display with primitive progressive scanning technology inside. The earliest adaptations of Baird's prototype were mechanical rather than the digital technology we're used to now, and relied on scanning vertical lines, achieving just 30 lines per frame. For some perspective, turn this video down to 144p, which scans 144 lines per frame. The earliest screens were about 5 times worse, which explains this terrible picture quality. From the 1930s, Marconi EMI's far superior electronic television sets appeared, and these were fitted with cathode ray tubes, which could produce 405 scan lines, 13.5 times more than Baird's mechanical TVs, and could now be measured using digital pixels. TVs like this 1948 Admiral model 19A12, costing $165.95, over $1,800 post-inflation, now had about 503 by 77 pixels in each frame and could produce 25 frames per second. After the advent of color TV in the 1960s, the next big development was the replacement of cathode ray technology with LCD display, which made TVs thinner by using liquid crystals instead of projecting images by splitting audio and visual signals into red, green, and blue lights. Pixel density, measured in megapixels per frame, which is 1 million pixels, is the best way to really see how far TV quality has come. With its 503 by 377 display, the earliest electronic TV had about 189,631 pixels per frame, which is over 5 times less pixels than a single megapixel. For some perspective, standard 1080p HD TVs have a 1920 by 1080p display, containing 2,073,600 pixels per frame, or 2.07 megapixels. That's almost 11 times more pixel density than the 1930s model. Even more modern 4K OLED UHD TVs start at 3840 by 2160p, or about 8.5 megapixels per frame, which is almost 44 times more than its ancestor, while the super impressive 8K UHD TV's 7680 by 4320p display has about 33.2 megapixels per frame. That's nearly 175 times more pixel density than the original electronic sets. Who knows how we might watch our favorite shows in the future, but this LG rollable TV, set for a 2020 release, is certainly a good indication. Which of these technological evolutions surprised you the most? Let me know in the comments below, and thanks for watching.